Hey, folks. It seems like
Hello.
our some of our graphics aren't working, so I apologize for the moment of silence there. So
Happy
today we
summertime Monday.
oh it's so hot here. I don't know
I know
about
it's gross.
you folks.
It's gross where I am too.
I know it's not
Hot.
probably not too hot where Sonny is because he's always been complaining that it's too cold.
It starts to be too hot to work on GraalVM, yeah, but
It starts to make the room hot.
yeah.
Awesome. So let's see. Before we actually let Sana take the floor, let's go over what we have for this week, which isn't much actually in terms of housekeeping. All we have is that we plan to release 2.0.0 final this week. So you have like maybe a couple days to get in your last feedback based on the 2.0.0 CR1 release. So do test that and then start using final when we release it. So Sanne, first of all, how about you introduce yourself for like some folks who haven't seen you
Okay.
here before?
Yeah. Hello, everyone. I'm Sanne Grinovero. I am Dutch and Italian, but moved to the UK when I was hired by Red Hat about 10 years ago. And I'm best known now as leading the Hibernate team. I also was in the initial, prototyping research project that led us to create Quarkus. Then I shifted back a bit more to Hibernate because we need to work on Hibernate as well. But yeah, so I have worked a lot on making Hibernate work in GraalVM initially, and more recently, sometimes I come back to optimize some things and try to make it consume even less memory, be even faster at runtime. That's always fun to try and get to the next level.
And to put some context on this for folks who don't like follow the dev mailing list or the dev chat, Sana is always the one that's coming in and saying, "Oh, you know what? I tried this under profile, and we're 20% heap size, larger heap size than 2 versions ago. So we got to fix this." So we're very grateful for Sana applying his profiling talents and being very curious, like what's going on, because he's found a lot of its underlying causes that you can like never have guessed. This causes
I find the
performance issues.
threads really fascinating to read. Because a lot of it, even though I've been using Java since the Stone Ages, like somebody else always knew that stuff, so I didn't have to know that stuff. So I just read and I'm like, this is blowing my mind. Like,
Yeah.
Sane, one of these days, I want
Thank you.
to organize some time so that I can just watch you do this because I'm like, I don't even know. I don't
That is
even
what.
know.
Before I report some success, there are lots of failures behind the scenes.
Well, I know, but like, I wouldn't even know.
But that's
Like what?
that's part of the deal, right? That you understand to distinguish what the failures are from the
Yeah,
successes when you're looking at this stuff, right?
yeah.
Okay.
That's
Well,
like I would just love. Somebody told me once upon a time, like, Aaron, you should Twitch your. I don't. You guys don't even want to watch me Twitch, but it would like you should just live stream with your code stuff. I would love a live stream of Sana figuring out what the heap usage is. I think it would be awesome.
well, we're trying to do a bit of that today, right?
Yeah.
But generally, I'm not sure I can keep it interested most of the time.
I don't know. I would just
But
be interested in Sana's litany of curse words. I think that'd be pretty good too.
okay. And yeah, by the way, within my team, we are starting to work much more in remote pair programming. Like I did a lot of pair programming in the past. It didn't really quite work remotely, like when I started it to try it some years ago. But the tools are way better now, and I'm really enjoying it. And I'm learning lots from others. Others are learning from me. So we could do that more often. I'm open to that.
Yay!
Yeah, I mean, what Aaron said is something that Sana and I have also talked about before. Is like everybody on the team is awesome, right? But everybody has these different skill sets and different ways of using their tools. And a lot of the times, because you're not working in the same office with somebody, you don't know how like they're using this super productive, super cool trick that like, yeah, you're doing like 10 steps to get somewhere and they're doing just like one step. And you're like, wow, that'll save me over like a day's work. A lot of time. Yeah. So that's something definitely looking forward to.
Yeah.
So, Sanne, what do you have for us?
So yeah, well, first off, I could talk for hours about these things. So let's try to cherry pick some things.
Excellent.
So yeah, I'm very passionate about trying to make sure that our stuff is lean and fast and efficient, like a pleasure to work with. And that means it's not just starting fast and consuming less memory. It's primarily a runtime performance what I'm interested in. Now, as it turns out, after many years of trying to make things go faster on the JVM, one learns that it's almost always coupled to have it consume less memory, so that the things go very much hand in hand. And yeah, there is a bit of history here. Like when I think it's been some years now, but we were mostly focused when maintaining Hibernate, like, it's about the feature sets, the ease of use, documentation, and performance was, of course, important to some set of customers as well. So we had a good eye on performance. There is a dedicated performance team that was keeping our metrics in check, like how many transactions per second can you do on this specific benchmark. But it was only until some members in the community raised an issue that they had this model that they were moving from Hibernate 4 to Hibernate 5. In the previous version, it was consuming like 300 megabytes of heap, and now it was consuming like 8 gigabytes of heap just to start the application. So that was much more heavy just to boot Hibernate. And yeah, my lesson learned from that is that that was the one metric that nobody was really paying attention to. Like every time we're evolving the code base, it wasn't really much of a concern of the team. Well, how much Java memory heap do you need? And to be fair, if you think about application servers and all that, if you had a requirement of running on 5 gigabyte of heap or 6, 7 gigabyte of heap, it wasn't going to concern anyone. That was a bit of standard things. Now, we patched that issue, and then Hibernate just boot went down from several gigabytes back to its 300, 400 megabytes of heap size. Now, mind you, this was a complex model, right? So like 1,000 different entities with lots of relations, lots of fields, columns, many metadata mapping on top of that. Still, 500 megabytes, if you add the rest of the application, it feels a bit much. Right? So that's been some years ago. I'm really happy to see like how far we are done with in Quarkus now. Can you share my screen?
Definitely. Yeah. There you go.
So I've used this demo many times. So let's not to focus too much on the code of the demo. That doesn't really matter much. But what I'm taking here is, so this is coming from our quick starts repository. It's the Hibernate ORM quick start. So what we have in here is, Hibernate ORM with the data source and the traditional blocking REST easy with the Jackson and the Postgres driver. Now, if we build this, and I happen to just have built it locally, well, in native as well, and so let me run this quickly. Well, it's up. It booted in there, 1 second, something. Pretty good. But now let's have a look at the memory in here and see how far we have come. So let me close and acquire a new heap up so you see that I'm not really cheating. And take a heap dump of this process. This is 9.4 megabytes. So we've gone down really from, well, to be fair, the gigabyte case was with a very complex model. Right? This is a very simple model. There is just a single entity, the fruit entity, which has, I believe, one attribute on top of primary key name. So 9 megabytes and counting, and that's not just the size of Hibernate. If you look at the Dominator tree, these are like a quick shortcut to see like what are the biggest objects that we have in this heap. And so they're sorted by size. The first one is the Quarkus cluster.
Sorry.
Yes. What's happening?
I know what happened, Georges. You're muted. If you're talking, you're muted. So you're doing something. Aha, there you go.
Everything's going wrong. Okay. I took your screen off and put it back on because it seemed on YouTube that your video was frozen. But anyway.
Yeah, it's not frozen, but it's not sharp either. At least not for me. It's okay. I can understand it. It might just be like.
Okay. Let's try this.
I can figure it out.
Yeah, no. Let's.
The details are not super important, right?
Mm-hmm.
If somebody cannot read exactly which class name it is, it doesn't matter.
Yeah.
So I mean, the top consumer in here. So just to recap, we are looking at the fully working application that's consuming just 9 megabytes of heap to boot, right? That's to boot. That's important. But the somebody's saying resolution is too low. What does it mean?
Yeah, that's not something we can control from here, to be honest.
I'm actually wondering if it's a clip.
It seems like it might be throttling your connection or something like that.
But that's okay. We can talk through it, and
it doesn't look too terrible actually. I have YouTube open as well, and it doesn't look that terrible. I mean, it's not awesome, but it doesn't look horrible.
Well, I'm sorry about that, but again, you don't really have to read the exact figures, right? And you can play along. You can download the same quick start and just have a look at the heap dump. This is Eclipse Math, by the way, Eclipse Memory Analyzer. It's another open source free tool from the Eclipse Foundation. It's really good. So this just gives me this quick summary, and it's telling me that the biggest object that we have here, or more like the biggest root of retainer objects, is the Quarkus class loader, which is about 1 megabyte. That's because the class loader does lots of very smart things to actually be fast and efficient for our purposes, like it pre-indexes things. But now the interesting thing from a Hibernate point of view is that Hibernate isn't even the second highest. Now, first we have the time zone definitions from the JDK. They take more memory, about 200 Ks, and then consuming 1.66% of the total heap size at 160 kilobytes, we have the session factory implementation, which is the root of Hibernate ORM. Well, these are estimates. You can use this function here to get the precise calculation. It's still, very, very close to that.
And just to mention this real quick, you don't have to use Eclipse Math. There are so many tools out there that will do heap dump analysis for you, right?
Right. This is just my favorite for heap.
Right.
But of course, I will switch to different tools for other purposes. Now, one thing of notice is that, by the way, this runner class loader thing, and this was twice the size just 2 weeks ago, when we noticed another small interesting optimization we could do in Quarkus, and that's what got us the application to be now under the 10 megabytes total size. Now, as I mentioned before,
I have a question before we continue. How many people got your poll correct? You had a poll on Twitter asking what the initial heap size would be. What was the percentage of people that got it correct?
Yeah, it was pretty good. It was like about 40%. 40% had it right.
So people expect that Quarkus is very, very small. That's cool.
Yes, or they expect that I'm cheating, or this is a trick question. What do you think?
No, I think we've set the bar really high.
Yeah,
and I think they know that. Like, if you're saying that that's it. You're not cheating. Like, yeah.
Yeah. Also, about that, the exact figure actually depends on the size of your machine, right? So for example, how many processors you're running. So in my case, let me just show that one. This is a 48-core machine, right? So, I mean, it's still 9
everybody
megabytes
has one of those in their
on a
basement. Oh
48-core
my god.
machine, right? Wrong picture. I lost another. There. No. So, this is a 9 megabyte heap size, even though I'm running on 48-core machine. If you're running this on a small constrained Docker environment, I expect this to be even less. Because if you look at what these objects actually are, especially when we put some load on it, then you have a vertex set and a netty buffer, which is precise depending on the vertex needs, and vertex is going to precise its own workers based on the amount of processors you're running. While if you have more cores, it's expected that the exact amount of memory will be a bit higher, and that's because we are not even optimizing like crazy for size. Right? The goal here is to get very high performance on the screen. Yeah, George is suggesting to lower my screen resolution, but I have just done that. I can try that more. Maybe I should try to restore default resolution. I'm pretty sure something is going to crash if I do that during the presentation. Let me try that.
Yeah, let's see. Being dangerous.
Does that still work? This is now my native screen resolution.
Now it seems way too small.
That's what I feared.
Yeah.
But is it less blurry? I mean, does it explain the problem at least?
Well, it's less blurry, but it's just too small to actually see anything.
Yeah, now the problem is, Eclipse Math isn't as fancy as IntelliJ giving me shortcuts to resize. So
I was actually thinking it's probably just Eclipse Math.
As well, it doesn't have great fonts.
Well, like you said, like it's not important to actually see the numbers, right? It's what you're explaining is basically the things that people should take away from this.
Yeah. Okay, a bit larger. I hope that's workable. Now, yeah. So why my obsession with the small heap size here? Now, of course, if we were to put some load on this application, the heap consumption would go up, of course, right? Some amount by depending what the code is actually doing in there. But I am very interested in taking a snapshot of the application when it's just started and not doing anything yet, because when we're building a native image in GraalVM, as you know, we are like pre-booting most of our frameworks, and we are generating constants that represent the application. Like it's not entirely booted, but let's say like 90% booted. So if I run it in JVM mode and then take a snapshot, it doesn't give me an exact picture of what will be captured in a native image, but it gives me a very close clue about what's being captured in native image. And if there is something standing out in here, I can very quickly check with the reports that GraalVM can generate and that Quarkus can generate if that same thing is also being captured in the native heap. And what we can see there is that what we capture in the native heap is taken as is, as a snapshot, and dumped into the native executable. So if I trim some megabytes of size here from useless stuff from this snapshot, it's going to trim by about 5 megabytes the size of the binary, which is interesting. And that's just a heap size, but we're interested in the code size in a native image because the more we can actually simplify the code to not include certain executable paths, that often has a very dramatic it has exponential impact potentially.
Right. Yeah.
On many other code that is dependent on that code and so on. Now, so let's have a look at an interesting case we had with XML parsers recently. So we were investigating why was
XML
one
parsers.
of our recent why was the binary size so much larger than a very older version of Quarkus. And so one thing I was very proud of when we did the very early prototype of Quarkus was that we were able to completely build Hibernate ORM in Quarkus in native without the XML parser that Hibernate typically uses to boot. So the first step of Hibernate to boot is, well, let's parse my configuration files. And you might have a persistence XML file or all the mapping files. And so, by the way, initially we cheated. We didn't support mapping files at all, but we still support the persistence XML file. Right? So you have to have a way to parse that. But the way Quarkus works is we parse all these configuration objects during the augmentation phase, which is build time, and then we don't really need the parser. So the code in ORM was carefully crafted so that GraalVM could see that the XML parser was not going to be necessary at runtime and be stripped out of the binary.
Now when we made this discovery, just to clarify, because I can't exactly remember, was it at one of our version boundaries, or was it at a Graal version change? Or was it a combination of both?
The regression, you mean?
Yeah.
It's hard to say because we did an integration test that was verifying that there was no parser included.
Okay, I couldn't remember if we remember, like I didn't remember from the conversation if it was a Graal changed or a we changed or everybody changed. So anyway, continue.
I think this was coupled by there were several factors at play. Right? Definitely a GraalVM change, but we also updated ORM code base a bit. We have a new Postgres driver version, and we'll see now the Postgres driver version was actually at play here.
Okay.
So yeah, the summary is we didn't have the XML parser included in the binary, and then suddenly we had it, and the size was fairly bit larger. That wasn't actually the only explanation for having us increase the size, but is one of them. So just why am I obsessed with XML parser?
Sorry, just Sonny, are you showing the IDE now? Oh, there you go. Okay, because earlier it was right. Okay.
So I just switched it to IDEA. This is the GraalVM source code. Don't worry, I'm not going in details of compiler technology here, but if you look into the GraalVM source code, first off, it's all Java, so it's very understandable for most of us who have some experience with Java. Now, the funny part is GraalVM evolved a lot over time, and it's trying now to automatically register what you might need at runtime if it suspects that you might need that thing. That helps a lot for onboarding, I guess, or it's probably a bit too intimidating to start with GraalVM when you have so many failures all over, and so it's trying to guess what you are going to need there. And I think this guesswork, it's not always perfect. So it tends to go on the safe side. So if it has this idea that, oh, I think you're going to use an XML parser here, let me include all of those things from the JDK that you will, maybe need if you actually have to parse an XML file at runtime. And so if you look at this is like the base class which handles the registration for resources related to XML parsers. And among them, it has small little things like, oh, you might need this class or this other class. And then there are, this is where I need your attention. Oh, and we have some additional resources that might be needed. with this line here, which has a little star in there. Now, if you take a heap dump,
seems innocent enough, right?
Yeah, if you take the heap dump, you discover that's all the error messages translated in all the supported languages, because it's a resource bundle that's triggering in, right? So you're registering like 200 additional resource files in the native image, which is absolutely great if you need an XML parser, right? But in our case, we were like, my demo was really not needing a parsing, so it's suddenly you have this additional like 5 megabytes of additional stuff in there. By the way,
this was the conversation. Was this the conversation where we were trying to figure out where, like, we were literally seeing all of those strings,
yes,
and how much heap all of those strings were taking up, and it was like, where it was exactly this. It was like, where did all of these strings come from? And so you had to search your way back.
I figured it points to that line there.
That is definitely finding a needle in a haystack. Let me go back. Oh, there's a star. That's where that's coming from. That's nuts.
And, well, tangentially, approximately at the same time, we have just merged an improvement in Quarkus, which now we actually support Hibernate ORM to have XML mappings. So, my first thought was, oh, okay, yeah, of course, I didn't add integration tests. Now we actually need to do parsing of more things. Of course, it goes south, right? But that wasn't the case. So that the execution of that new feature has been absolutely great. What was happening was a really obscure code path, and I'm going to switch to the Hibernate ORM project. Now, you should know, if you're using Postgres, only if you're using Postgres, the database is able to support column types of UUID type. And Hibernate knows about this feature, so it registers a custom type. The type for us is a custom way to map a Java object to a specific database column type. Now, this custom type is automatically registering if you're using Postgres. And what it does is to map a UID object. It's going to be set on the Postgres driver by using statement.setObject, because that's the way that the Postgres team documents, how do you set a custom UID type? Well, you just use setObject for that. Now, of course, setObject is a bit generic, and it is coming from the other way around. Oops, lost. SetObject is GDBC spec, so you can set many different types of objects in there. And then if you look in the Postgres GDBC driver, you will see that setObject, first off, it makes some special exception clause for the UID case, in which then it's going to go for setUID, which is like a proprietary extension here. Otherwise, it's going to use the SQL types and blah, blah. It could be any of these other things, including it could be an XML object.
Nice.
Now,
so sneaky.
Lovely.
Very sneaky. Now, I was a bit surprised here initially, because clearly here we know that this method, when it's reached, it's only going to be reached. And we see this by the reachability tree. It's only being reached by that UID type, which means we're only ever invoking this code if this is a UID type. So if it's a UID type, it's not going to be an XML type. Would you agree? But this is probably one of those cases in which the complexity of the code is surpassing the ability of GraalVM to maintain the context for long enough to see that this method here is actually dead code.
Especially when we all complain about how long it takes, right?
Yes.
It would have to do even more analysis, which would make that native compile even longer.
That's exactly what I'm trying to also fight here. When we are keeping the application small and keep these initial heap sizes and the amount of code that needs to be included small, that has a very strong impact on the compilation times.
Right.
And yeah, we have seen recently, even in the community, some reports of people that there were some other changes that I'm not going to talk about now, which got GraalVM to consume a bit more memory, not much, like 20%, but that led him to take way more time because the machine wasn't prepared to consume that much more heap size. Anyway, back to this point. So what we do about this? This is a case in which the GraalVM compiler is being confused by this. Now, to be fair, one thing that I hope to be able to do, I didn't really have the time, is to try to synthesize like a simpler reproducer and share that with the GraalVM team, because there might be something here with the type flow that could be optimized, and it would be really nice if the compiler could automatically prune code that's dead. But now what we did is a substitution for the Postgres driver, which we have now in the Quarkus code base. Let me switch again. Yeah, so let me start with a high-level discussion first. What I wanted to do there is to have the compiler automatically not include XML parsers, but only if you're not actually using that feature. Because if you're using that feature, I don't want to break your code. It's a legitimate feature that you might actually need in your code. So we want to make the application smaller with no XML parsers for all the guys that don't use XML parsers in their application. But we still want to have an XML parser, of course, when there is a legitimate use.
Right, yeah.
Now, that got us into a bit of creative thinking here. The basic idea is that reflection, we have always considered reflection to be like the evil thing, because when you register something for being accessible for reflection, via reflection in GraalVM, what happens is that code becomes a possible target site for any code which is doing a reflective invocation. And then, of course, it might try to prune it a bit based on, like, okay, it doesn't implement the right interface, or it's not right the right. But it's obfuscating a lot to the GraalVM's capability to actually optimize the code. Now, I was interested in this idea that it's obfuscating it. Right? So if I intentionally do a reflective call from one method to another, the GraalVM compiler is not going to be able to see that I'm invoking that method. Right? Or is it? In practice, it's actually able to see trivial invocations. So if you're invoking a method and have that method's name as a constant in your reflective call, the compiler catches it and knows, aha, you're going to invoke that specific method here. So it's quite clever. But what we can do is, if I introduce a reflective call anywhere in our code, and then I register that call for reflection, then it's still going to work as before, right? And we don't have to worry about the JVM mode, because JVM mode is the JVMs are able to optimize reflective calls really well. After some time, of course, so not immediately, but it's not going to matter much for actual runtime performance. By the way, it doesn't matter at all in this case because it's a substitution, so it's not going to make any difference in non-native code. But in GraalVM mode, if I introduce a reflective call and then register it for reflection, what happens in principle is it keeps working, but I get a switch. I can decide to turn it off or on from our build items or from something else.
Right.
And the other switches we have is reachability is pluggable in GraalVM. So what we do here is we register that in the before analysis phase, so before GraalVM is going to analyze all the code base, we set a trigger that we have a reachability handler, which is this one, on the set result method on the PG SQL XML. Now, I'm going to spare you some deeper details, but essentially what happens is if you ever invoke set result in your code on the Postgres, on this type from Postgres, then that code path we have seen before is actually maybe ever sometimes invoked. So in that case, I don't want to remove this feature from it.
Right.
So what we do is, well, if you have any code anywhere which is reachable in turn, reaching into this set result, then we register my custom new method for reflection, the really process DOM result.
I know, I love it. It is just as good as my naming. It's awesome.
And then, we replace so this DOM helper actually didn't want to replace the class in Postgres driver is pretty large, and I don't want to replace some parts of it. So I had it just replace the little piece to invoke the DOM helper. And the DOM helper is going to do, maybe process DOM result, which means it's going to invoke that method reflectively. And then that method, which is invoked reflectively, this is, the same code that would normally trigger those XML registrations. So if this is registered, then the XML parsers get included because all of this code needs to work. And in addition, we have to obfuscate the method name, because if I were to write this in here,
yeah, I would figure it out.
It would figure it out. It would just register that for reflection in all cases. So
wow, that's
this
awesome.
is fragile, right? Because what happens in the next version of GraalVM, if they become a bit smarter and see that this is a constant, well, we'll have a test failing, and they'll have even more motivation to actually produce a reproducer and go talk with the GraalVM team, make this better, right? But what's the impact of all of this? Well, now we have integration tests which verify that there is an integration test with XML using the Postgres parser and an integration test without XML for the Postgres parser, in which the binary of this one is about 4 megabytes smaller than the binary with this one, which is
very nice.
Our goal.
Very nice.
Now, the bigger complexity here was to figure out that the XML parsers were being included because Hibernate has a feature to store UIDs in Postgres. That was really tricky because the code, how do you call this? The reports that GraalVM produce, which include the call tree of the whole application, they are extremely large. So when you are looking for something specific, that hasn't been working really well for us. So Galder created a new tool that's, it's a patch for GraalVM that allows us to dump all of those symbols of the call tree into a Neo4j or another if you want to. It can. Initially, it was just for Neo4j, but then he patched it to generate data for any graph database. And then I can now query the graph database. And so when you have a doubt, like, OK, I'm looking at a small application here, and I see from the contents of the binary, that what's included in the binary, I see it's including some stuff which I did not expect to be there. Then I can query this over with the graph engine to see, well, who reached this, and that gives me then a clue about why.
Yeah, that's awesome. Yeah, is this tool merged yet in GraalVM?
I'm not sure. I think last time I looked at this, it was approved. Yeah, I expect it to be there very soon. Right?
Great. Yeah, because those CSV files are like, you just can't work with that stuff, right?
Yeah, it's too large. It works well if you're having, I remember, before we started Quarkus, we were like doing hello world prototypes. It was helpful, but now that we have all of these libraries in there, and like in this case, they interact in a very weird way. Like if you just had the same test not running on Postgres, we would not have Okay, Galder is saying not yet integrated. But yeah, I'm optimistic that it's going to be there very soon.
Fingers crossed.
Okay.
Yeah, I mean, from what the analysis you just performed here to show us like how this stuff interplays, you just can't figure this out unless you have the right tools to look at like what's going on, right? Because there's just so much stuff going on here that it's impossible to keep all this stuff in your head and look at it and say, oh yeah, this really is triggering, and you just can't do it without the tools.
And yeah, so why does it matter so much for me to remove these 5 megabytes here, 3 megabytes there? It's because they always have like a composite impact among them, right? You know, if you don't remove XML parser in a case in which there really is no need, then it also becomes harder to you know, create other optimizations, because then you want to add an integration test or regression test, which is verifying, you know, this simple case is not going to include certain code, but then it's being pulled in by other code, which is just not being optimized. Let's switch to next topic here.
Cool, yeah.
Okay, well, in terms of demos, I don't really have much more. I just wanted to discuss about why that was important. So like I know, for example, the Spring team and the Spring Native and the GraalVM team, they've been working on like integration of unit testing within GraalVM, which is a new feature in GraalVM. And now, since this code is interacting with each other so much, and as you have seen here, you know, there are these cases in which, you know, the GraalVM autonomously decides, okay, I've seen this constant, so let's automatically register this additional reflective call, this additional method for reflection in there. And this actually has an impact on what's included in there, and also like on which resources are being included. So my concern with that approach is really that the native that you're generating has like semantics which are directly affected by the unit tests which are included.
Right, yeah, because there's so much stuff coming in because of the test, right?
Right. And now, why do we test native images? That's the bigger question, right? We can, you know, if the GraalVM compiler was perfect and didn't need any additional rules like additional reflection, additional resources being explicitly specified by you know, our command line tools or extensions or, you know, or the Quarkus build items. If none of that was necessary, we would just be running tests on JVM, and then we compile them to native. We would expect that to, you know, just be working as well. But if this native testing is additionally automatically registering code and possibly resources because it's triggering some of these rules in the image, then it's no longer a good tool for me to verify that these rules that I have put in place to actually include resources or register things for reflection are actually correct.
Right, because you're not going to know. You're not going to know if paths have been added or removed or whatever, because your conditions are different.
Yes, but also it's very possible that you know, I think I could easily craft an example in which, you know, some piece of code which is otherwise dead is invoking, say, you know, it's invoking this method with the name. And so since it's not dead because this code is exercised by the test, this method is now being registered by reflection. But
so
then
yeah,
if I remove the test, that method is no longer being invoked by reflection, but maybe this same method is also invoked by reflection by some other piece of code, which is now completely broken.
Right, but my understanding, which is poor, so you can correct my bad understanding, is that when you're using native images for unit test, or when you're trying to run your unit tests in native mode, they were still trying to get it to work with their usual. So like Spring does a lot to be able, or they invest a lot in their testing infrastructure so that you can write very isolated tests. So while I can understand that your dead code path analysis and whatever wouldn't necessarily be accurate because you're mocking or you're otherwise masking around.
But are you suggesting they create a new native image for every single test?
I'm not sure. That's the part I haven't looked at in detail.
Expensive.
That would take forever, right? I mean,
right, but I think okay.
And to what benefit for the user?
I think it's not the benefit to the user at all. The whole point has nothing to do with the end user, the end user of the service. It's about the developer still being able to write those tests in isolation for a given service. But I agree with you that most of the problems that you get into with native, when you're writing stuff that runs in native code, is reachability problems ultimately. And so your native test doesn't help with that, right?
Well, yeah,
that's my point, right? Since reachability is what you are testing, but this affects the reachability, then that's a problem.
So I'm trying to get to the point in a different way to make sure I understand it, because my brain is stupid. I mean, are there other things? It's also Monday morning and whatever, so brain is just not here. Are there other behaviors, though, that you could test that aren't related to reachability that would also be different? Like, I can picture from my own experience with writing the micrometer stuff, for example, that I could have written unit tests in the way that they have them against some of the low-level beans or other things, and I would be able to see that they're not working properly. It is a reachability question, but it's not something that it's like the beans don't even exist. And I don't know that I would have needed the testing long term. So
yeah, but if you're testing like that, wouldn't JVM testing wouldn't that cover your needs anyway?
No, it would definitely not, because there are because God, you're hitting me with things. Because in the case of the micrometer stuff, it's literally using things that are present in JVM mode that are not in native mode. So if I had my unit test that was like looking at just JVM metrics, for example, or thread pool metrics, or like there's I think it's a GC metrics or whatever. If I had written my unit test the normal way to verify my capability, and then I flipped over to native mode, it all would have died a terrible death, because that stuff just is, because it's running in native mode. It's not like there's stuff that's just missing. It doesn't exist at all. GraalVM doesn't have it. Forbidden APIs came across as a comment. That's another one. Right? So reachability isn't necessarily there. It's just, am I on a code path that is allowed in native mode? Because sometimes that's just different. It's not quite a reachability problem. It's just the function does not exist.
Yeah, absolutely. I wasn't meaning to say it's a completely useless feature. I did not mean at all to bash on it. Just
well, I'm just trying to understand.
My
I haven't digested.
That we can't really,
Yeah, I haven't really digested. Like, I haven't tried to go back through Spring native mode, which is not fair of me, right? That's something that I intend to do on one of these days. I'm just going to go write a Spring application and go through their Spring native unit testing, because for me, the value that I see, Georgios, again, it's not for the end user. It's for the developer that's used to writing these isolated tests in the way that's the Spring workflow that Spring has. And it's more about that to verify this little thing. But I think this is highlighting that it doesn't help you identify reachability problems, because with the extra test stuff, your reachability stuff is going to be all muddy, is what you're saying, or is what this is highlighting. So it would depend, I guess, on what you're trying to test.
Yeah, right. In our case, it's really like, I mean, in the Quarkus case, at least we want stuff to be really small, and we want stuff to be, processed as much during build time. So that approach of testing just wouldn't really help.
And
Right.
we don't want users to have to create additional native images, right?
Yes.
Well, I think right. I think because of the compile time hit, right? Because of the compile time hit, that's the issue.
And that's not like a detail, right? Because on my
Yeah,
machine,
it's non-trivial, or it's
on
it's
my
a big
machine,
deal.
which is, it's not 48 cores, but it's 32 cores. A hello world takes 45 seconds. So
Yeah, long enough to go and refill your coffee.
yeah, and this is a brand new machine. I mean, I would never run 100 of those tests, even on this machine, right?
Right. That's the workflow question that I have outstanding, Georgios. That's why I'm asking it the way that I'm asking. I don't know if anybody else is making sense. For me, it's a workflow question. They're trying to preserve or continue a workflow. I haven't experienced the ramifications.
Right. Yeah, I haven't used it either. So yeah, there might
so
be
anybody
something
in the chat or come into Zulip and yell at us. It's great. Because I need to learn it anyway. So
yeah. And yeah, on the Hibernate side, like I'm showing the source code of Hibernate ORM now. I just wanted to mention we also have GraalVM features in Hibernate ORM now, which are not depending on Quarkus. This was suggested by the GraalVM team that, since we had done all of this analysis work to make sure that Hibernate was working in GraalVM, that we could create a model which could be more generally reused by others. So I created it, except it's not really easy to decide which list of features need to be statically included for everyone. So this for those who don't know, there is a Hibernate-GraalVM artifact ID in Maven, which matches all the releases of Hibernate. And this will register automatically if it's on the class path and you're building a native image. It's going to register all the essential needs that Hibernate is most definitely going to need to work. But it's not going to register many things which are potentially optional, or depending on what you actually want to do, because of this risk of increasing the size of the code way too much for what you really need. So, for example, even Quarkus is depending on this one. So we have this shared set of static GraalVM resource inclusions, and which then get augmented automatically, dynamically, depending on the configuration of the Quarkus application, the entities of your model, and so on, and whatever else we can detect during the build time. There are some things that we can improve further, though, which is, for example, I just made, this is a toy, but it's working fine. So I decided that all of the antler nodes, so when we're parsing any string for a query from the query language, we use antler. And antler, the version 2, which is what we're using in this older version, has all of these nodes that you can see here. So the node support, order by fragments, or specific, there is a long list here of things which the antler parser needs to be able to instantiate via reflection. So if you have ever any use for the HQL interpreter or parser, you are going to need all of these reflective classes registered. So we are registering them statically, but just for the fun of it, I recently improved that to also use a reachability handler, so that all of these things are only being registered if you're actually ever reaching the code which is parsing a query.
Nice. Just for fun, because
just for fun, because it doesn't it doesn't actually, because I'm learning how these things could potentially evolve and interact with other optimizations.
Yeah.
Now I did it, and I hope it's going to be useful at some point. But I know that today is pretty much useless because all code is reaching these parsers if you're using Hibernate for various reasons. So that gives me a list of other optimizations that we haven't done yet, but we can do. For example, by working on this, I noticed that, at the very beginning, I said we bootstrap our frameworks, like 80-90% of them, but there are some last bits of things that we need to do at runtime. Right? For example, Hibernate is designed to boot most of it, but then there is a point in time during a bootstrap in which we have to validate your tables in the database. I cannot do that during build time because you probably won't like to give me access to your production database during the build. So there is this point, and then there are some things which happen later. Now, I just noticed that among the things that happen later, we do things like validation of named queries for syntax.
That could definitely happen earlier, right?
Right. So we just have to move some stuff around in the Hibernate code base and make sure that that's happening before this specific point. And but such things are also having an impact again on reachability, right? Because maybe you never want to use an HQL parser in your code because you just do find by class and ID, and maybe you have some really simple code. But we have intentional code, which is, after the boot, you're going to, take this map of strings, which is the named queries, and you're going to parse them to validate them, right? So that's going to trigger inclusion of all of the entler parser nodes as well. No big deal. We can still, boot in 20 milliseconds, but it's going to be nice to, work on all of those components.
Well, parsing the named queries early should also give you better feedback if your syntax is wrong. Right?
Yes, we should get that feedback during the build, which is amazing. Now you're getting it when you're starting, which is, that feels like old Hibernate style.
Yeah.
Yeah, and that's a theme from a Quarkus theme that we've been like hammering that point from the beginning, right? That as much as we can move to build time, both for performance reasons and for user experience reasons, right? Like all this stuff, you shouldn't. Well, we've already done a lot of stuff, but as you mentioned, there's more to do. Like some of these errors, like it doesn't make sense to wait for runtime to display to a user.
Yeah. There is another case in which we are using actual parsers at bootstrap time. And you might think it's silly. Let me switch back to the quick start. So, in the quick start, you have, the option to import a query. Like here, a script of stuff that's going to run when we first connect to the database, right? And this is often used to see the application with like the demo code. Now, what you might not know is that we actually parse the script because we need to identify what are the terminators of this. So, you can, if you want to, format this nicer in a different way.
I love listening to you type. Listening to you type reminds me of my old mechanical keyboard that I sounded like a rampaging herd of rhinoceros. It's great.
Yeah, everyone wants to use a different keyboard when I present, but
no way, man! It's awesome.
My keyboard.
I love it.
It's awesome.
So, yeah, so your scripts can be formatted as you like them, right? And which means we have to parse them. And yeah, as it turns out, when I was working on this, I figured that, we're also parsing your import SQL after booting, just before executing those statements. So, more nice things that we can do. And if we do that, like if we do both of these optimizations, then you still can't
So how do you do the parsing? How do you do the parsing of this at build time? Do you put a digested form into the app? Did I just miss that? That's totally me. I probably got distracted by rampaging rhinoceros.
We can, if I just parse this and make it, this is an array of strings, and each string is a statement.
Oh,
this
right.
array
And
of
so you're
strings.
putting that so that you would that be
What
like
I'm-
a bytecode recording thing?
Yes.
Ah, okay. Well, that's
It's
what
just
I'm trying
another
to understand. Like, if you're
concept.
Yeah,
right,
well,
exactly.
I think the point here is that this file is not changeable at runtime, right? So it's a
Exactly. So
class
you're
path
digesting it
resource
into.
that is only settable at build time.
Yeah. Okay. So you're taking the parsed result and bytecoding it, and then at runtime it's just reading or it's just using what it already knows.
Right. At runtime, we can still say decide to honor maybe different. Is this runtime? I don't think so. But none of these are runtime properties. And, well, I guess this is a great example of why most Hibernate properties are build-time exclusive, because there are
Right.
so many very strong optimizations that we can only do if we agree that these are not going to mutate after stuff.
Right. Now, I do have a question because I know that takes people by surprise very frequently. So, would you ever consider the case where someone opts out of those optimizations and they say, no, really, for real, I want to be able to defer this stuff till later and take the cost?
We have some of those discussions. Like there are, when Quarkus 1.0 was launched, we really focused on making things work from the initial ideas, and so it was just a very simple thing. It's all build time, of course. Except these ones, which you probably don't want to hardcode.
Right. The credential ones are the obvious ones. I just know we get a lot of questions about late binding
we keep getting many of those. In some cases, we were able to relax the thing, but I always have to take that with extreme care, because when we are relaxing a property to be runtime as well, it's very hard to then change later, and we really have to think of when this property is being processed and what impact it has on other code, which needs to be made constant after a certain point in time. So, for example, the database kind, like a very big question that comes out often is like, oh, I need to build this application, but then I need to choose if it's Postgres or Oracle or MySQL later.
Yep, that's the one I keep hearing about.
Yes, that's a big no-no. That is really hard. And well, now that you know how much memory this is costing, starting all of this is 160 kilobytes. So our official answer to that is, just start 3 of them. It's 160 kilobytes each. That's not going to be the end of it. But the opposite is say if I had a property here which is allowing it some syntax like this, and different one that at runtime you have to choose one of them. Right, that's another thing that we have added. The problem is that the impact of the dialect is so large on all of the Hibernate code base that, well, first off, it would be a 6-month work for us to actually work. Even assuming that's not a problem, to be twice as large, because we will need to be including all of these specifics into that binary. So you might as well just include 2 database data sources.
Well, it's not only GraalVM, right? This is also has an effect on JVM, because like you're saying, you're looking at all these heap optimizations, but if you can't with constants make the JVM compiler know what to load or not, then you're going to get a whole bunch of more classes loaded, right?
Right, but that's why I'm asking if it ends up being a opt-in trade-off. Like, no, for real, I know this is going to make my app big, but I need to do this. Thank you. Stop yelling at me.
Use a different framework.
Ouch, Georgios! Ouch! Oh, stab me in the heart. Oh, wounded.
Well, no. Okay, yeah, that's a little heavy, but like Sanne said, there's always a point that has to be drawn, right? It can't be everything for everybody.
But I think we could do something like, say, this syntax, drafted here, and then at runtime you need to have a different file which is picking off them, and then you had some kind of validation that this one needs to be one of those that you listed above. Right? So like, this is not an open-ended choice. Like you can't deal with Postgres Oracle and then say, well, that's equal runtime.
Right.
Good at that. Right? What we could do is some sugarcoating here, in which, under the hood, we actually have two Hibernate instances, and then depending on what you're doing at runtime, we
add one or remove the other or whatever. Right? Yeah. So Georgios, that's right. I'm asking the question only because the user requests have been coming in, and so I just wanted to ask what that would look like to see if anybody else listening or watching this later is like, oh, this is super important to me, and I would be okay with this trade-off.
Yeah, but okay, that's sure. That person would be okay with the trade-off, but would everybody else that would be negatively affected?
Well, that's why
like okay with their trade-off.
Well, I think what Sanne has just said means you would have to opt in to see this behavior. It would only happen if you specify more than one.
Let me put it this way, the way I see it: if that could be done, and the engineering cost, not both to build it and to support it, would not be large, then that sounds great to me. But nothing is free, right? Like for Sonny to do this, he would have to not work on something else that could also potentially be really important.
Which is why we would need users to
absolutely.
Yeah, that's what
I don't claim to have the answers. I'm just trying to make a.
You're just being grumpy, is what it is. It's Monday.
No, I'm being the devil's advocate.
I know users would love it. But still a matter of
the thing is
it's complicated.
Yes, I mean, so that's what I wanted to try to articulate, because users ask, why isn't this possible? And there are two reasons, right? There's a storage cost and there's a complexity cost. And so the question is, how important is it to the people who are asking for this feature? Do they understand the ramifications, or is it just what they're used to? That was what I was trying to poke at, right? I'm not saying yes, it's the best thing. I just know the question has come up a lot, so I figured I'd ask.
Yeah. So in my experience, so of course I have had lots of questions that come this way, right? And yes, it's something that people really ask for, but in many cases when they adjust their mindset about how things actually work in Quarkus, then they're okay with it. So a part of me is also trying to stand our ground, because people just have to think.
And that's a fine answer too, which anybody watching, I mean, that's the same as when people are trying to wrap their heads around why microservices are different than monoliths. It's like there's stuff you just shouldn't do anymore. And once you get your brain wrapped around, oh, there's a whole new way of doing things for this, then things you were worried about stop becoming interesting, or, there stop being things you worry about because you realize you shouldn't be doing it that way. Anyway, thank you for letting me poke on that.
Yeah, this is an extreme case, right? There are other properties in Hibernate that we actually did make a runtime after some careful consideration. In some cases, I'm already regretting it, but there are some middle grounds, right? So there is this one is a definitely no. This one is a definitely yes. And the other ones will think about them carefully.
So we have also changed properties from build time to runtime in other parts of Quarkus as well. But it always involves a lot of consideration and
And there are more costs than storage, right? It's not just about storing two versions, because then all of your invocations suddenly they're no longer inlineable. You're going to have runtime performance penalties.
Yeah, exactly. Well, we're about 10 minutes over, so unless we have any final really important points.
Any questions from external? I can't really see much.
Nothing so far. If you have any questions, any final questions, add them in the chat. Or if you don't get the time to, you can always reach out to us on Quarkus Dev List or Zulip. We're always happy to answer. Just don't ask to make DB kind runtime. No, I'm just kidding. I'm just kidding, because a lot of times we hear stuff that we're like initially, this doesn't make any sense, but it turns out that it does. So cool. Well, thank you very much for your time, Sonny. This was really enlightening.
This is so cool.
Fun. Really fun.
Awesome, and see everybody soon.
Bye. Thank you.
Bye-bye.
Have a good week.